All right, guys, let's start off here on number 4. So this one, we're gonna grab all these functions and their domains. So for the domains, actually, because all of these are gonna inherit the kind of original domains, I'm gonna go off to the left here and I'm gonna establish those. And so for f, the domain would be that the inside of that radical must be greater than or equal to 0. So that's I would go ahead and factor that. And then I need to use my test points here, so that's -3 and that's +3 with the closed dots. And then I need to do my test points, so if x equals -4, that's going to be positive and negative, so that's negative. And then if x equals 0, that would be positive, so that's a positive. And then if x equals 4, that would be a negative and then a positive, so that would be negative. So this one, my domain is between -3 and 3. All right, and then for the g function, my domain is x squared minus 4 greater than or equal to 0. So this one would be x plus 2, x minus 2 greater than or equal to 0. Again, test points, -2 and 2, closed dots. This one, if you tested it, would actually come out plus, minus, plus. And so that's out here and over there. So the domain on this one is actually going to be -∞ to -2, union 2 to infinity. All right, so that's going to help me here as I go along. So for f plus g of x, I would say that I'm just going to add the radicals together. Now, we're not allowed to add radicals that have kind of different things in them, so this one I'm actually done. Now, the domain on this one, we have to kind of combine the domains of the original two functions that I did over here. So I need to find some x values that really fit into both. And so what you might want to do here is kind of visualize this on the number line. So I'll go ahead and draw my number line here. And kind of the key points on both of those are -2. Actually, -3 is first, then -2, then 2 and 3. And so I'll kind of color code this to help visualize it. So the red one is kind of in between here. And then the blue one is going this way and that way. So we see kind of the only space that has both is this area right here and this area right here. So that is actually our domain, -3, -2, union 2, 3. Awesome. All right, next up we have f minus g of x, which is actually going to be very similar, except this time we're going to subtract the functions. And this really doesn't change anything about our domain here. So I'm just going to copy my domain from the previous question. Like I said before, it's really just the kind of what takes into account both of those earlier domains. Oops. All right. All right, next up we have f times g of x. So for this, we're going to multiply them together. So I'm going to do rad 9 minus x squared times rad x squared minus 4. And so on this one, when we're multiplying two radicals, even if they're different, we are allowed to multiply their insides together. So I'm going to go ahead and do that. And then I'm going to go ahead and FOIL this, but I'm going to need some more space, so hold on. All right, so this one, when I FOIL it inside of the radical, is going to be -x to the 4th. I got -4x, actually that's positive 4x squared, positive 9x squared makes positive 13x squared, and then minus 36. And then this is actually going to have that same domain again. We're still going to restrict it to -3 to -2, just like I said before, the combination of those two domains. All right, lastly, we're going to do f over g of x. And for this one, let's see, what's our f here is rad 9 minus x squared, and then the bottom one here is x squared minus 4. I don't really see anything I can do to simplify that one, so I'm going to leave my answer like that. The domain on this one is going to be very similar except for one thing, and that is on this one, x cannot equal plus or minus 2. Because that radical is now in the denominator, the negative 2 and the positive 2 are just going to switch into parentheses. But everything else would be the same. All right, next up here we'll do 18. We'll start with A. So 18A, we're going to do f, the inside first, f of 4. So 3 times 4 minus 5, and that's 12 minus 5, so that's 7. And then I take that 7 and I plug it back into the function, so 3 times 7 minus 5, 21 minus 5 is going to be 16 for my final answer there. Then for part B, g of 3, I'm going to do the inside first, g of 3, 2 minus 3 squared, and that's going to be 2 minus 9, which is negative 7. So then I need to do g of negative 7, which is 2 minus negative 7 squared. Now I cannot do minus minus to plus plus there because I have to do the exponent first, so that is negative 47. All right, next up I got 38. So I need to do all of those functions, f of g, kind of every direction and their domains, okay? So I'm going to do f of g of x first. So in this case, that's going to be f of x squared minus 4x. And so that'll be 1 over the square root of x squared minus 4x. Okay, so now I need to look at the domain of the inner function and the final answer on these ones. So for the inner function, I have no domain restrictions. And then for the final answer, though, I have a radical in the denominator. So I would say the inside of that radical must be greater than 0. Normally radicals are greater than or equal to 0, but when it's in the denominator, it cannot equal 0. So I'm going to factor that. And then I need to do some test points here. So I'm going to do 0, I'm going to do 4. These are both open dots here. And if you test it out, it's going to go plus minus plus. I kind of just think of this as a positive parabola. So the domain on this one would be negative infinity to 0, and then 4 to infinity. All right, I'll fit g of f of x in here as well. So now I'm going to do g of, and I'll replace f with, what's our f function? 1 over rad x. And so that's going to turn into 1 over rad x squared minus 4 times 1 over rad x. Now when I square this first one, that's just going to be 1 over x. And then this one will be 4 over radical x. We can actually, we could do a common denominator here if we wanted to. So I would multiply this by rad x over rad x, which would actually make this 1 minus 4 rad x over just regular old x there. And so I would probably write my answer like that. Okay, now for domain, for my inner function, I see here I had a radical in the denominator, so that means that the inside of that radical must be greater than 0. On my final answer, I actually kind of have a couple of radicals here. So I have this one up, or actually I have a couple restrictions. I have this x in the radical, I have this x in the denominator. So I would say that because of the x in the radical, it must be greater than or equal to 0, but because of the x in the denominator, it cannot equal 0. So these really all mean the same thing. So then I would just say the domain here is parentheses 0 to infinity. It's got to be greater than 0. All right, next up, we're going to do f of x. So this one would be f of 1 over rad x. And so then I'd have to plug that back in. Okay, I'm kind of thinking right now that I can think of a better way to do this. I would actually define f of x as x to the power of negative 1/2. I think that that's just an easier way to do this. It is the same thing. It's a negative because it's in the denominator and a 1/2 because it's in the radical. So I'm actually going to do this as x to the power of negative 1/2. and then I'm actually going to plug that in, x to the power of -1/2 to the power of -1/2. And then if I simplify that, that means multiplying the exponents, so that's going to turn into the 1/4 power. Now, if I want to translate that back, it is going to be the 4th root of x. I would probably do that since that's how the question was written. And so now when we look at domain, for our inner function, we would have to say, because that x is in the denominator, the inside of the radical must be greater than 0. Once again, normally the radical is greater than or equal to, but because it's in the denominator, I go greater than, just greater than. My final answer, actually, since it's not in the denominator anymore, would be x is greater than or equal to 0. But since the x is greater than 0 is more restrictive, I'm going to use that one as my domain. So I do need to exclude the answer of 0, so it's going to be 0 to infinity with parentheses. All right, now I need to do g of x. So for this one, it's going to be g of x squared minus 4x. And so that means I need to go in there and plug in x squared minus 4x in for every x. Okay, so the first one here, I need to write it twice and FOIL it. So that's going to be x to the 4th minus 8x to the 3rd, and then plus 16x squared. And then over here, I'm going to distribute that -4 in there. And then I'll just combine my like terms. Okay, and that's good to go. Now on this one, I would say the domain is -infinity to infinity because I have not had any radicals nor denominators throughout this whole problem. All right, next up we'll do number 42. So on this one, they want us to do f of g of h. So I'm going to rewrite it like this, which is how I prefer it written. Okay, so we're going to do the inside first. So I'm going to leave f and g alone, and then I'm going to replace h with x squared plus 2. And then now I'm going to take that and I'm going to plug it into the g function. So that's going to be parentheses x squared plus 2 to the 3rd. And now I'm going to take that and plug it into the f function. So that's going to be 1 over x squared plus 2 to the 3rd. You could expand that x squared plus 2 to the 3rd, but I'm not going to. I would just leave it like that. All right, next up we got number 50 here. So this one we are trying to kind of work backwards and come up with two functions that I could have plugged in here to get this result on number 50. So if I was doing this as f of g of x, just kind of remember here that g of x is the one that's inside here. And so to me, it looks like that's a rad x there. There's more than one way to do these, but the way I see that g of x, I would make it rad x. And then it looks like that got plugged into f of x, which would have been just the square root of 1 plus x. So if we replace that x with a rad x, we would have gotten that end result. So it's just kind of thinking backwards. All right, next up here, you got number 57. So I'll let you guys try that one out. You can check your answer in the back of the book. All right, next up here, number 60. So it says you got a $50 coupon for a cell phone, and then another one you have 20% off. Let x represent the regular price of the phone. So then A says write a function f that models it with just the 20% discount. So then I would say f of x equals, and I always think if it's 20% off, that means I really have to still pay 80% of it. So I would say 0.8x or 0.80x. So that's just, if I had a 20% off coupon, I would just have to pay 80% of the original price, so 0.8x. Part B then asks, what if you had the $50 coupon? So that would be g of x, and that would be x minus 50. The coupon just takes off $50. And then the next question on part C asks, which would you prefer, f of g of x? I didn't quite write that right. F of g of x or g of f of x. It says it a little more wordy than that, but that's basically the idea here. So what I would do is I would actually check these out. So if I did f of g of x, I would get, let's see, that would be f of x minus 50. And so that would be 0.8 parentheses x minus 50, which would actually simplify to 0.8x minus 40. Whereas g of f of x, would be g of 0.8x, and so that would be 0.8x minus 50, which actually does not simplify. So I could make up a random number here for x, but I think it's pretty clear to see here. If I was the customer, kind of depends who I was, but if I was the customer, I would prefer this order. Because you can see that they're going to multiply the price by 0.8 and then subtract 50 because of the order in which they did it. Now, if I was the store, I would actually prefer this method because that would mean that I would be charging the customers more, so I would make $10 more.